Hey guys, we're going to be working on 7.3 today, or 7-3, which is kind of real word problem. All right, so Carlos is giving his friend in another state a new umbrella as a gift. He wants to ship the umbrella in a box he already has. Which box can Carlos use to ship the umbrella, and explain? So I'm going to, there's a couple ways to think about this. I'm just going to test the biggest one right here, okay, to see if it'll fit in there. So we have 27 on the bottom, so right here, and we have 27 right here because it matches that 27, right? So right there. So we can see if it'll kind of just go like that, okay? So what we'll do is we'll say A and B, and we'll figure out our C, right? So A squared plus B squared equals C squared is going to be 27 squared plus 27 squared equals C squared, right? And so I'm going to show you a little trick here that you can do to kind of put this all in your calculator. You can actually square root ahead of time, so you get your C value out right away. And then you can kind of just put that whole thing into your calculator, whether it's a graphing calculator or your Desmos calculator. Hold on 1 second here. Okay, so we can actually, just put this whole thing in here into the Desmos calculator. Let me zoom in because the glare is kind of like not awesome on this. Okay, so focus back a little bit. Okay, so we'll put in 27 squared plus 27 squared, and then this will take care of the whole thing for us, right? So we end up getting a C value of 38.1, and let's say 38.2 if we round it, inches. And then we'll compare it to our umbrella, which is 37.5. So that'll work, actually. So we can actually fit this umbrella in here, and it'll work, right? But since this is a three-dimensional problem, right, we have these three-dimensional boxes, we can actually see if rather than fitting like, how should I? Rather than fitting like, oh, it's going to be hard to say, like, like this, right, kind of that way, we can actually kind of angle it in to take advantage of that third dimension in there, which will give us a slightly longer hypotenuse on there. So what we'll actually have to do is solve a little bit extra. So we know it's going to fit in this one regardless, right? It'll fit kind of whether we put it flush against right here or if we kind of put it kind of like diagonally from this corner to that corner, right? So let's try it on this one. So we'll see if it'll fit from that corner to that corner right there. So what we have to do is we actually have to figure out the side right here, because that'll give us that, and then we'll have that like diagonal going through the middle. So well, we've got this here. We have this 22 and this 22. So we'll put this in here. We'll say 22 squared plus 22 squared equals our C value, right? But it's going to be the square root of that. So that's what we'll put in here, and that'll give us this dimension. And then we'll kind of do a second problem to figure out the cross diagonal, I suppose, right? So we say square root of 22 squared plus 22 squared gets us to 31.1. So this right here, so the C value of this one, so we're going to do multiple iterations, right, of the equation, right? So we have the diagonal from this corner to that corner is 31.1. Now what we can do is we can figure out the kind of interior cross diagonal going from here and here. So this is our A, that'll be our B, right? So we'll say, and I'll just kind of put it in one line right there. This is this problem right here, right? So we'll say square root of 22 squared plus 31.1 squared gives us 38.1 for that one. So let's see, let's write it out here. 22 squared plus 31.1 squared equals C. So that second one gives us 38.1, which actually would fit it as well, right? Because it's longer than that, 37.5. So this box would actually work if you put it like kind of cross diagonal from the one edge or one corner to the other corner right there. So that one would work as well. Now let's try this last box and we'll do the same thing, right? So we'll figure out the diagonal kind of through the bottom right there. So we've got our A and our B. So let's see, our A is 22 plus 27 squared. That'll be our C. Again, the fact that we have this calculator makes this so much easier, right? So we've got 22 squared plus 27 squared gives us 34.8 along the bottom right here. 0.8, okay? And so then we'll figure out the diagonal right here. So it's 14 by 34.8, right? So 14 squared plus 34.8 squared equals C. And again, makes it super easy. We'll just put it in here. Square root of 14 squared plus 34.8 squared gives us 37.5 inches, which I think it'll just fit in there. So it'll be a real tight fit on that last box. But yeah, they'll all fit. So a couple different ways to think about that. Probably the easiest way is just kind of pick the one that looks the biggest and then test it. And then you can kind of go around the other ones right there. Or you can literally just put the umbrella in the box and see if it works. Okay. Kiana is using a kit to build the kite shown here. The kit includes 3 different lengths of wooden dowels. How can Kiana decide which pieces of wood to use as diagonal braces for the top or bottom of the kite? So, oh yeah, okay, cool. So we've got this rectangle right here is basically the bottom or the top of the kite. So we're figuring out this length right here and which of those 3 to use. So this is our A value, that's our B value, and we're looking for our C value. So super simple to set up, right? We've got 21 squared plus, 28 squared equals C squared. And yeah, I mean, let's just use the calculator. Well, you guys don't have, I guess if you have decimals, let's just do this the old-fashioned way. 21 squared is going to give us 441 plus 28 squared is 784, and then equals C squared, and then we add them, and then we'll square root it. So 441 plus 784 gives us 1225. Yeah. Sorry, you guys can't even see what the math I'm doing. My bad. 21 squared, right? 21 squared is 441. 28 squared is 784. And then we add them together to get to 1225. And then we'll square root on both sides. And we get 35. 35 inches, which is this. Can you guys see that? Yeah, you guys saw it good. That dowel right there, that 35-inch dowel right there. So what is the length of the diagonal D of a rectangle with length 19 feet and width 17 feet? So 17 is the shorter one, so I'll put that as our A. That's our B. So I'll put that as 19 right there. So that's a 17. Sorry, my handwriting is terrible this morning. Let's see, 17 squared is 289. 19 squared is 361. Add them together. Let's see, 289 plus 361 gets us to 650. And then we square root on both sides. Gets us to 65, so 25.5 for our answer right there, 25.5. Alex has a column aquarium with a rectangular base that has a height of 66 inches, a length of 10 inches, and a width of 14.5. What is the longest piece of cholla wood that Alex can buy to fitness tank? I'm assuming cholla wood is something you would put in an aquarium. I have no idea, honestly. Okay, so the idea here is we're going to kind of do that same thing. We got to do 2 sets of problems, right, to be able to figure out this line right here. So we'll use that as our A and that as our B in our first problem, okay? So we've got 10 squared plus 14.5 squared equals c squared, okay? And I'm just going to square root it and do the easy way, right? So c is the square root of 10 squared plus 14.5 squared. And I'll just throw this whole thing in the calculator. Okay, so square root of 10 squared plus 14.5 squared right there gives us 17.6 inches for this length right here, okay? And then we have this right here. So this will be our new A value, and this will be our new B value, right? Okay, so then it's going to be 17.6 squared plus 66 squared equals c squared. So we square root here, and yeah, I'll just do the easy way again. 17.6 squared plus 66 squared. I'll just throw this in the calculator. Over here, maybe. There we go. Okay. So square root of 17.6 squared plus 66 squared, and it gets square rooted to be 68.3. So that is what we're looking at right there. That's our ultimate answer to get that length right there of cholla wood, which never heard of because I'm not an aquarium guy. That's what are you going to do? Okay, apply the converse of the Pythagorean theorem to solve problems. Again, the converse is when you test a triangle to see if it is a right triangle. You basically put your A, B, and your C in, and you see if it works out to a true statement. So Sandra bought a triangular shelf to hang in the corner of her room. Will this shelf fit in the 90-degree corner? Again, this is we're testing to see if it's a 90-degree angle. We're testing to see if it's a right triangle. Okay, so A, B, C. Again, it's A squared plus B squared equals C squared. Okay, so this is 18 squared plus 24 squared equals 30 squared. So I know that's just going to give me 900. Okay. And then 18 squared is 324. 24 squared, oops. Nope, come on. 24 squared is 576. And now we'll see if they add up. So 576 plus 324 gives us 900. Look at that. 900 equals 900. That is a true statement. So yes, this is a right triangle. And there you go. Okay, we'll fold this in half. And since my notebook is all the way on the other side of the room, you guys don't need to see me put that in there. But yeah, there you go, guys.